Okay, for this section, I think I want you to grab some colored pencils. It might be helpful if you grab the same colors. I'm using a green, orange, blue, and red. I think this section might be helpful if we use some colored pencils. So take a second to grab some colored pencils to do this one. This is going to be a little bit of a review. For example 1, they want us to figure out angle X. Well, remember that all the way around a circle it's 360 degrees. So if you took 360 and subtracted the arc on the outside they've already given us, that would make this arc right here 160 degrees. And a central angle and a arc measure are always equal, so that means it's 160. On the next one, they want the arc here. If you add 140 and 170 together and then subtract that from 160, let's go ahead and do that. 140 and 170, what is that, 310? And then you take 360 and subtract 310. That's going to give you a 50. So that means this remaining arc, not the dotted part, but the part out here, is only 50 degrees. So the intercepted, the inscribed angle is also, now this one's half. It's not a central angle, it's a inscribed angle. So it's half of that. Take half of 50. This one's new. This one, let's talk about this theorem. If a secant and a tangent intersect at a point of tangency, then the measure of each angle formed is half the measure of the intercepted arc. So it's a lot like an inscribed angle where it's two secants or two chords. This one is still, the angle here is always going to be half the arc here. So if we double it, that makes it 60. Okay. Example 4. The arc here is given as 11x plus 2, and they want us to find what this arc degree would be. Now remember that if we double 89, that'll give us the measure of this arc. So if you know that if you take 89 and you multiply it by 2, that's going to give you 178. So you're going to have to say that 11x plus 2 is going to equal to 178. Now you just solve for x. If you subtract 2, you get 11x is equal to 176. If you divide 176 by 11, you'll get 16. So x is 16. Just remember that it's always half. This angle in here is half this arc, so just double that. Take 89, multiply it by 2. That's how we got the 178. This is the arc. Okay, here's where I kind of want you to use some colored pencils. Let's see. If two secants intersect in the interior of the circle, then the measure of the angle formed by is half the sum of the measure of the arcs intercepted by the angle and its vertical angle. Okay, that's kind of confusing, but what that means is if you have lines crossing and the intercepted arcs, and I'm just going to color this one orange and the other one I'll color green. You don't have to color them, but it kind of helps. So if you have any kind of crossing lines, they could be secants or chords. If they cross and they tell you the angle degrees, the sum right here, this word sum, half the sum, means you're going to add them and take half. So let's write that as a formula. We know that our central angle or the vertical angle, they're talking about either one, has to equal half. The sum means you add the 70 and 30 So that's how you figure out your central angle. Now you can put it in the calculator if you want. You can, probably this one you can do in your head. 70 plus 30 is 100. Half of 100, x is 50. So let's try the next one. Alright, this one's talking about an outside angle. They call it an exterior. So if secants or a secant and a tangent or two tangents, really doesn't matter. If lines are intersecting and they're on the outside, it's half the positive difference of the measures of the intercepted arcs. So what that means, let's use our green and red again. If you were to take the arc, I'm going to color it green, it goes all the way to this point. Now the one they gave us is 150. Let's color that one orange. So see the two parts of the circle, we have the green part and the orange part. The word difference, where is it? Yeah, half the difference. Up here it was half the sum. This one's half the positive difference. That just means you're going to subtract the two arcs. Well, on this one, if you notice, they didn't give us the green one. Well, 360, let me write that down. 360 subtract 150 is 210. So 210, let's go ahead and write it out here. 210 would be the degree of my green arc. Well, half the difference means you're going to take 210 and subtract 150. Now that capitalized the word positive. If you had flipped this backwards, you would have gotten a negative. So just make sure you always subtract the smaller arc and then take half. So when you take half that difference, you're going to get, let me make sure I'm going to do this in the calculator. Yeah, 210 minus 150, that's going to be half of 60, and half of 60 is 30. So that means your exterior angle. Just remember when it's on the outside, it's, I think I'll even circle that word, it's half the difference. Half the sum up here. So it's, when you're looking at an inside angle, it's a sum. When you're looking at an outside angle, it's a difference of the arcs. Half the difference. Alright. Here's another example using that. See how we have an outside angle? So it's going to be half the difference of the two. Now this one, they gave you, I'm going to go ahead and use my colors again. And if I color one of the arcs here, and the other arc, the one closer to the angle, you see where the little line is right here? Put a little dot there. That'll help you understand that when they put a little dashed line here, that means this green part, this arc, this part of that circle. This orange part is already given to us. It's 150. But because we're looking for an outside angle, you subtract those intercepted arcs. So to find, or to get the angle 40, you had to take half of 150 minus something. We don't know. We don't really know. This is the one we're looking for. Now to solve a problem like this, I think it's easier to multiply both sides by 2 to get rid of the 1/2, because if you multiply this side of the equation by 2, half of 2 is 1, so you end up with 150 minus x. If you multiply this side by 2, you get 80. Let me know if you don't understand that, but that's the best way to get rid of a 1/2. So on this one now we subtract 150. Now this will give you a negative 70. Let me show you. If you subtract 150 from 80, you'll get a negative 70. Now just pay attention to the sign in front of the x. See how that's a negative x? So when you divide out your negative 1, your x would equal 70. And if you want to check it, just let's put it in the calculator real quick. If you put in 150 minus 70, you get 80, and half of 80 is 40. So it does give you the outside angle. So you still set it up where you have half the difference of the two arcs. Here's another one that's on the outside, so we have to subtract the arcs and get the angle. So your equation is going to say this angle, the one with the expression x plus 25, is equal to half the difference. Now always take the bigger arc first, so I would take the one out here, the 4x plus 5, and subtract the inner degree, which is 50. So this is a little bit longer equation, but we can do it. The easiest way to get rid of the 1/2 again is to multiply both sides by 2. Now I think I'm going to show that. If I multiplied both sides of this equation by 2, the 4x, and I'll go ahead and put the 5 minus 50, that'd be a negative 45. And then doubling, just be careful when you multiply both sides by 2. Over here you need to take it and make it 2x plus 50, because you have to distribute the 2. I'm going to move the 2x to keep it positive, so I get 50 is equal to 2x minus 45. I'm going to add 45 to 50, that's going to be 95. Divide 95 by 2. Looks like I'm going to get a decimal, 47.5. Make sure that's right. I'm going to put it in my calculator here. What was it? Yeah, 47.5. I'm sorry, I'm just checking something, make sure it's right. 47.5 you know what I'm going to do? I'm going to put in 47.5 plus 5. I'm going to go ahead and label that up here. That would make this a 52.5 degree angle. Now if we did the difference, half the difference, 52.5 minus 50, that's not working. That's, oh, I forgot to multiply by 4, sorry. 4 times 47.5 plus 5. I knew that didn't sound right. Let's fix that. That makes this, sorry, this is 195. Now if we do the 195, I'm going to put it down here. If we check it, we're going to do 195 minus 50, and then we're going to take half of that and get the outside angle. So 195 minus 50, half of that is 72.5. Well, if we replace the 47.5 back in, let's see if it works. 47.5 plus 25, it is, this angle right here is a 72.5 degree angle. So you take that, subtract that, take half, it gives you the outside angle. That one was a little bit, oh, I'm sorry, I just looked at the screen and it didn't show up. You might want to play that back a minute. I moved it up to help you see all the work up here, but the little circles up there that I put on the degrees, that's just going to help you check it. Let's go ahead and fill in our answer. Our answer for x was 47.5. If they want the degree answer, you would have to replace the x. Just make sure when you work in the worksheet that you look at that. Okay.